Good morning everyone. Today we will discuss about how to formulate a linear programming problem. See, formulating a linear programming problem involves structuring the problems into a mathematical format where we will define the decision variables, we will identify our objective function, and what are the various constraints in the given problems. And the formulation lies the foundation of finding a optimal solution to a complex real world decision making problems. So therefore, we will discuss today the stepwise procedures to formulate a particular problem by taking a particular examples. See, what are the various steps in the formulation of linear programming problem? It involves various steps which mainly include defining a decision variable, identifying objective function, and what are the various constraints. So here we will discuss the general outline of the steps involved in the formulation of linear programming problem. See, the first one, it is we have to identify the decision variable. See, determining the variables representing the quantities or action you want to decide upon. And after identifying the decision variable involved in the given problem, express these variables in terms of algebraic symbols, just like it may be x1, x2, x3, or maybe in the form of x, y, z, like that. See, after identifying the decision variable, then the next step is to define the objective function, where we will determine what are the goal or the objective we want to optimize. So it could be, a maximization of profit, or maybe a minimization of cost, or maybe the maximization of efficiency, or maybe achieving some other quantitative aims, which is entirely depending upon the nature of given problems. So here we are expressing the objective function as a linear combination of decision variables with coefficient representing their contribution. Then after defining the objective function, then we have to identify the constraint. So the identifying the limitations or the restrictions on the decision variables. So here the constraints can be two types, or maybe it can be expressed in terms of equality constraint or maybe inequality constraint, and express each constraint mathematically as a linear equation or inequality involving various decision variables. Then after that, we have to check the non-negativity. That means check whether the decision variables are constrained to non-negative values or not. If so, then add non-negativity constraint, that is, we are generally assuming that the concerned variable is greater than or equal to 0 for those particular variables. So these are the general steps in the formulation of linear programming problem. Now we are going to consider one particular problem. See, consider a chocolate manufacturing company that produces only two types of chocolate, that is X and Y. For the production of these chocolate require two main inputs, just like milk and choco. The manufacture each unit choco X and Y, it require different quantities or inputs of the milk and choco. See here, for producing each unit of chocolate X, it require 1 unit of milk and 3 unit of choco, and similarly in each unit of Y, it require 1 unit of milk and 2 unit of choco. So here the company has the total of, here we have a limitation, a total of 5 units of milk and 12 unit of choco. And on each sale of this product, that is chocolate X and Y, the company make profit of rupees 6 per unit when the chocolate X is sold, and rupees 5 per unit when the chocolate Y is sold. So here our problem is how many units of X and Y should be produced so as to maximize our profit. So here we want to formulate a linear programming problem. Now let us see how we can frame it. See, we are going to formulate linear programming problem here with one of the suitable example what we are given the problem. Consider the chocolate manufacturing company. We are already said they produce only two types of chocolate. I am writing here the chocolate X and Y. So here X and Y are the two decision variable. It is decision variable which are written in a vertical format. So for the production of these chocolate X and Y, they require two input. What are the two input? It is one is milk and another one is choco. So in the given in the given problem, it is mentioned that in order to manufacture each unit of commodity X and Y, that means chocolate X and Y, it requires different quantities of milk and choco. For example, for producing each unit of chocolate X, it require, in the given question, it require 1 unit of milk and 3 unit of choco. I am going to add here, in order to produce chocolate X, 1 unit of milk and 3 unit of choco. Similarly, in order to producing each unit of choco, in order to produce each unit of chocolate Y, it require 1 unit of milk and 2 unit of choco. I am writing here in this particular format. Now in the given question, there is a one limitation. What was that particular limitation? That is generally known as it is constraint. The company has the total of 5 units of milk and 12 units of choco. So we are going to add here that particular limitation, that is the total of milks are 5 and choco are 12. So I have just added here, this is one of the limitation. So on each sale of chocolate X and chocolate Y, the company make a profit. In the given problem, it is mentioned that company make a profit of 6 rupees per unit in the chocolate X is sold and 5 per unit in the case of chocolate Y is sold. So I am going to add here the profit per unit of, if you go for selling the X, then the producer will get 6 rupees and Y he will get 5 rupees. So now I am going to put all these values in a table. It will be look like this. See, this is a table representing. So with this given situation, now the company wants to maximize the profit. And I am writing here how many units. So the company wants to maximize the profit and we want to identify that how many unit of commodity X, that is chocolate X and Y, should be produced. So this is our problem. See, by using this particular example, we want to identify what are the decision variable. Then we are going for identifying our objective function. Then we will go for identifying what are the various constraints. Then the non-negativity constraints. So here, first we are going to identify, see what are the decision variable we have. See, in our example, the manufacturing chocolate, see, we now formally define some of the terms, like the first one is decision variable in order to solve the linear programming problem. So the first step is that we have to identify what are the decision variables in the given problem. So these are the unknown quantities that are expected to be estimated as an output of linear programming solution. So here in the given question, see, we have chocolate X and Y will become. See, this is the outcome variable. So we can say that chocolate X and Y will become the decision variable here, because it shows that the quantities or decision that producer want to determine how many units of chocolate X and chocolate Y is to be produced. So that's why we are saying that it is the quantities or decision that producer want to determine. So in the question, it is given that how many units of X and Y should be produced by a particular producer so as to maximize the profit. So here the decision variables will be, see, chocolate X and chocolate Y. So we are identifying what are the various decision variables. See, after identifying the decision variables, the next step is to identify the objective function. So the second one is that the identification of the objective function in the linear programming problem. So it is already defined that the objective function, see, it is the decision making variable related to the decision making variable, and all the linear programming problem have an objective function, which may be either in the form of maximization of profit or maybe in the form of minimization of cost, like that. So there are some numerical values representing the profit or maybe cost or maybe some production quantity. So in our example, see, the company wants to maximize the profit. It was already mentioned in the given problem. Company wants to maximize the profit. So profit maximization is the objective function. So here, by using that particular given problem, the profit, that is, company make the profit of rupees 6 per unit of chocolate X when it is sold and 5 rupees per unit of chocolate Y when it is sold. So the total profit is represented by, for example, it is, I am denoting in terms of Z. So here the 5 and 6, or sorry, 6 and 5 will be the coefficient of the objective function of the concerned variable X and Y. So here I am showing here the objective function here, it is profit maximization will be the objective function, and we want to maximize Z is equal to, see, 6X and 5Y. That profit is want to maximize by the producer. So here, after defining the objective function, now our next task is to formulate, to identify the constraint. See, identification of constraint, which are the restrictions or the limitations on the decision variables. And they usually limits the variables of decision variable. And for example, the limits on the here, the availability of milk and choco. In our given example, the limitations were how much units of the milk and choco is available. So here, especially for producing, chocolate X and Y, so as to maximize the profit by the producer. But the availability of the resources like milk and choco required for the production of both chocolate are very limited, which are restrict the production capacity of the producer. So as per our example, see, each unit of the chocolate X and Y require 1 unit of milk and see, as per our example, see, each unit of chocolate X and Y require 1 unit of milk, and the total amount of milk available is only 5 units. This is the one of the restriction. So this can be mathematically represented as, see, here I am denoting here, it is X plus Y less than equal to 5. I am denoting the sign here, inequality, that is less than equal to 5. That means the maximum milk is available 5 unit. So it is less than or equal to 5. It cannot be more than 5. Similarly, for producing each unit of chocolate X and Y, it requires 3 units of choco and 2 units and 3 units and 2 units of choco. So the total amount of choco is available here, it is only 12 units. So again, this is another restriction. Availability of choco is also another restriction. Maximum available units of choco is 12 units. So again, I am here representing mathematically the second one, that is 3x plus 2y, which is less than equal to 12 units. So now this is in the standard form of the linear programming. These are the various things. All the constraints, see, we have a 2 constraint, 2 variable we have 2 constraints as well. All the constraints are in the form of an equation, that is x plus y is less than equal to 5. Then 3x plus 2y is less than equal to 12. So these are the constraints in the given problem. Now after that, the last step we have to identify that non-negativity constraint. Non-negativity constraint is another one. So each variable in the linear programming problem must be positive. We are already defined why it is so. And the negative values, non-negative values, irrespective of whether your objective function is maximization or minimization, it does not matter. So we should need a positive value. So this is the critical restriction as far as all the linear programming problem is concerned, which means that the value of the decision variables should be greater than or equal to 0. So in our example, we have 2 constraints, so that is x and y. We have 2 variables are there. So I am writing here the non-negativity constraint, that is x is greater than equal to 0 and y is also greater than equal to 0. So now we can write all these steps in a simplified mathematical format. So here see our given problem I have converting in the mathematical format, that is maximize the profit, that is z is equal to 6x plus 5y subjected to the linear constraint. See, we are identified two constraints, that is x plus y which is less than equal to 5, 3x plus 2y which is equal to or less than 12. Then after that we have a non-negativity constraint, that is x is greater than equal to 0 and y is greater than equal to 0. So we have formulated here the real world problem into a mathematical model. See, this is the entire model, mathematical model. Now this linear programming model problem is ready for finding the solution. It is not a solution. We are just identified how to formulate the linear programming problem mathematically. So this problem formulation is actually related to the maximization problem, that is maximization of profit here. Now we are going to consider another problem that is related to the minimization of cost. So the problem number 2, see, we have food X1 which contain 134 units of protein, carbohydrate and fats respectively in kilogram. Similarly, food X2 which contain 2, 1 and 3 units of the protein, carbohydrate and fat respectively per kilogram. Suppose 2, 3, 6 units of the protein, carbohydrate and fats respectively are the minimum daily requirement for a poor patient. So here, if X1 is cost, that is food X1 is cost 4 rupees per kilogram and X2 is cost 2 rupees per kilogram. Now our problem is that how many kilograms of each one should the poor patient buy per day to minimize his cost and still meet the minimum requirements. So here we want to formulate a linear programming problem. So with the given problem, see, the first we are going to identify the variables. See here in the given problem, see food X1 and X2. How many unit of the food X1 and X2 to be produced with the minimizing cost and still meet the minimum daily protein requirements. So here the food X1 and X2 will become, the decision variables. Now the food X1 and X2 which having, containing different units of the protein, carbohydrate and fat. So the food X1 contains some units of protein, carbohydrate and fat. See, food X1 in the given problem, it's saying that food X1 contain 1 unit of protein, 3 unit of carbohydrate and 4 units of fat. I am just going to write here 1 units of protein, 3 units of carbohydrate and 4 units of fats. Then after that, the food X2 which contain 2 units of protein, 1 units of carbohydrate and 3 units of fat. So I am just writing here it is 2 units of protein, 1 unit of carbohydrate and 3 units of fat. Now after that, there are some other information given that suppose we have 2, 3, 6 units of protein, carbohydrate and fats which are the minimum daily requirements for the poor patient. So this is given in the problem, that is for a poor patient minimum daily requirement will be. So I am writing here what are the minimum daily requirements are 2 protein, 3 units of carbohydrate and 6 units of fat. These are the minimum daily requirement. So at the same time we have also given in the given problem there are some other information is given, that is the cost of food X1 and the cost of food X2 is given. So I am also going to add here the cost of food X1, it is 4 rupee per kilogram and the cost of X2, food X2 which is rupees 2 per kilogram, 2 rupees per kilogram. So our problem is now how many kilograms of each one should be poor patient buy, that is X1, how many units of the food X1 and X2 that a poor patient buy in order to minimize the cost with at the same time he wants to meet his minimum calorie requirements, that is the daily requirements are also given. So I am denoting this is in the form of a particular table. So here by using this particular table, now we can formulate what are the various decision variables, then identify what are the objective function, then what are the various limitations, then non-negativity. So here the first one is we want to find out what are the decision variable. We are already said that food X1, how many units of food X1 and X2 that poor patient buy. So here the decision variable will be food X1 and food X2. Now after identifying the decision variable, see the next step is to specify what is our objective function. See what is our objective function in this case? It is the minimization of the cost. The cost wants to be minimized. So what is the cost of food X1, which is equal to 4 rupees, food X2, which is equal to 2 rupees. So we can write the objective function here, it is cost minimization, and we want to minimize the cost, that is 4x1 and 2x2. This is the cost minimization. So here minimize the C, I am denoting denote the cost which is equal to 4x1 and 4x2. Now after specifying our objective function, see next one is that we have a certain limitations or restrictions given in the given problem. So the next one is what are the various constraints. See the constraints are given in the form of protein and carbohydrate and fat, which are the minimum daily requirement for a poor patient. So for the poor patient, minimum daily requirement of the protein is equal to 2, carbohydrate is equal to 3 and fat is equal to 6 by consuming X1 and X2. So here I am constructing the first constraint, that is X1 protein, X1 that is only 1, X2 2x2, which is minimum of greater than or equal to. See I am denoting here the term greater than or equal to. In the last example I have shown that it was less than or equal to, but here it is greater than or equal to. Why it is so? Because here our statement is minimum daily requirement. So minimum he should consume or he should have 2 units of protein, not less than that. So that's why I am putting it is minimum is equal to 2 or greater than 2 protein. So I am putting this particular sign, that is greater than or equal to 2. Similarly, this is the first one, that is first constraint. The second constraint is related to the carbohydrate. How many units which will be minimum daily minimum requirement of a carbohydrate, that is 3 units. So here we can write it is 3x1 2x2 greater than or equal to 3. So I am writing here this is our second constraint. And the third constraint here, see it will become fat, related to the fat. See 4 units of x1, 3 units of x2, and at the same time he should have the minimum daily requirement of the fat which is equal to or greater than 6. Minimum is 6, so it may be greater than 6. So I am denoting here the sign that is in terms of greater than or equal to 6. It is mandatory, especially in the case of a minimization of problem, mostly your sign will be it is greater than or equal to. In the case of a maximization of profit, generally it is less than or equal to. But in our case, our objective function is cost minimization. So it is, the sign is here, it is greater than or equal to, because the minimum daily requirement is 2 units of the protein, 3 units of carbohydrate and 6 units of fat. Now we are specified our constraint. Then after specifying our constraint, next one is that we have to go for specifying that non-negativity constraint. So here our variables, that is x1 and x2, that cannot be negative, should be greater than or equal to 0. You know what is the reason behind it? It does not, if it is negative, then it does not, it cannot give any particular interpretation. So it will be a wrong interpretation will be done. So we are going to specify here our variables, that is x1 is greater than or equal to 0. Similarly, x2 is also greater than or equal to 0. Now our model is completed. We have specified our decision variable. We are identified our objective function. We are also formed the various constraints which are given in the problem, and we are also specified that the variables are non-negative. Now we can say that we have a mathematical formulation. So here I am showing in the given problem we want to minimize the cost. So the cost minimization here, it is 4x1 plus 2x2 subjected to the system of linear constraint, that is linear constraints are here, it is x1 plus 2x2 which is greater than or equal to 2. This is the first constraint, and subjected to the another constraint, that is 3x1 plus x2 which is also greater than or equal to 3, and the third constraint, that is x1 4x1 plus 3x2 which is greater than or equal to 6. So it is in the form of, the first one, it was in the form of protein, carbohydrate, and in the form of fat. So this is the various constraint. Then after that we have a specifying non-negativity constraint of variable, that is x1 is equal to greater than equal to 0 and x2 is also greater than equal to 0. So in this way we can formulate a real world complex problem into a simplified mathematical model. See, now the model is completed here. We can use this particular model and we can find the solution for this particular model, and accordingly we can identify how many units of the food x1, food x2 that a poor patient can be consumed at the same time with the requirement of, minimum requirement of fat, protein and carbohydrate, and at the same time he also wants to minimize the cost. So this system is completed here, that is linear programming problem is formulated here. So after formulating the problem, see, next we want to find out the solution. So in order to find out the solution, see, the various methods are there, especially for finding the solution of a linear programming problem. But in this particular course, we are mainly focusing only on the two popular methods for the finding the solution of linear programming problem. One is graphical method and another one is simplex method. So by using the graphical method or the simplex method, you can find the solution for the linear programming problem, and these two methods we will discuss in the upcoming classes, and I hope the formulation of linear programming problem is clear to you. We will see in the next lecture. Thank you.